A short time ago, an American airplane dropped one bomb on Hiroshima and destroyed its usefulness to the enemy. That bomb has more power than 20,000 tons of TNT. The Japanese began the war from the air at Pearl Harbor. They have been repaid many-fold, and the end is not yet. With this bomb, we have now added a new and revolutionary increase in destruction to supplement the growing power of our armed forces. In their present form, these bombs are now in production, and even more powerful forms are in development. It is an atomic bomb. It is a harnessing of the basic power of the universe. The force from which the sun draws its power has been loosed against those who brought war to the Far East.
On August 6, 1945, the world witnessed the dawn of a new era, an atomic era, marked by the dropping of the atomic bomb on Hiroshima, Japan. Days later, atomic energy would end World War II, manifested through the second atomic bomb dropping on Nagasaki, Japan. With the ending of World War II and the beginning of the atomic era, a nuclear arms race between the United States and the Soviet Union began to unfold, particularly when in 1949 the Soviets entered the atomic world with a demonstration of their own atomic weaponry. In the deserts of the western United States, the atomic era acted as a testing ground for this weaponry and the destructive power of atomic energy, with above-ground weapons testing in Nevada and New Mexico.
Now let's go back and see it again in stop motion. The light flash, the heat wave, and clouds of dust. Keep your eye on the house on the right. Notice how the heat wave affects it. There's the fire starting in the trash surrounding the house. Now it spreads to the house itself. In a moment, the blast wave, and here it comes. The house on the right is the first to ignite. The trash serves as kindling.
From this arms race came a climate of fear, as historian Spencer R. Weir has stated, "Fears were magnified during the Cold War. When mushroom clouds no longer needed to be imagined, they appeared on the evening news." Yet, while the deserts of the American West captivated the public with their scenes of atomic destruction, one atomic testing ground provided a more humble design for the advancement of atomic technology. Without the visually stunning appearance of mushroom clouds, this test site proved to be no less important than its more popular and publicized counterparts. Within the vastness of the sage-covered Big Lost River Desert in eastern Idaho, a nuclear testing facility was established in 1949, while the Soviet Union was demonstrating its atomic weaponry for the first time. This facility, known as the National Reactor Testing Station, was tasked with the development of peaceful applications of nuclear energy for civilian and defensive purposes, primarily in the forms of energy production and propulsion. Emphasizing the importance of this nuclear facility in East Idaho, Dr. Jack M. Hall explained in an article for the Pacific Northwest Quarterly, "The atomic pioneers who settled around the Big Lost River Basin between 1949 and 1962 came to Idaho to build new machines for the nuclear age. Theirs was a national mission, entrusted to the Atomic Energy Commission by the United States Congress." During the atomic era, the National Reactor Testing Station, now known as the Idaho National Laboratory, provided pivotal advancements in the field of atomic energy, culminating in a series of atomic firsts and demonstrating a side of the atomic era beyond the destructive military applications for which the era is most well known. During its time as the National Reactor Testing Station, the nuclear site of eastern Idaho brought 52 experimental nuclear reactors to fruition during the atomic era, the first of which being the Experimental Breeder Reactor 1. Experimental Breeder Reactor 1, also known as EBR-1, was established in the first years of the new nuclear facility, beginning operation on August 24, 1951, and tasked with a mission to generate its own power through atomic energy. This was achieved on December 20, 1951, when EBR-1 utilized energy created through its own atomic power to light 4 light bulbs. Historian Jonathan Melville expanded on this occurrence, stating, "At 1:50 p.m. on December 20th, 1951, in the tiny town of Arco, Idaho, Experimental Breeder Reactor 1 powered on for the first time. For 22 short minutes, the light bulbs above the heads of the scientists were lit not by inspiration, but by nuclear power." The following day, the EBR-1 took its experiment to another level, when it began powering the entire plant. In a cold and barren snow-covered stretch of desert, the EBR-1 made history as the first facility in the world to create sustainable power using atomic energy. Additionally, the EBR-1's success had been further amplified as it was able to generate more energy than it consumed, making its breakthrough all the more important for future applications of atomic energy. Success of the EBR-1 would become just one of the many important advances in nuclear energy over the next 10 years. While civilian applications for atomic energy encompassed a large portion of the work done at the National Reactor Testing Station, the nuclear facility was always connected with military applications as well, albeit in a manner different from the weapons testing at other facilities within the western United States. From its inception, the nuclear site has worked in partnership with the United States Department of the Navy in the development and testing of nuclear submarines. This collaboration with the Navy led to another atomic breakthrough for the world when, building on the advancements of the EBR-1, the testing station created the world's first nuclear-powered engine and demonstrated its use within the world's first nuclear submarine prototype in mid-1953. By 1954, that engine would be used by the world's first nuclear submarine, the USS Nautilus. While the world's first self-propelling nuclear engine was established in 1953, another event would occur at the end of that year which would lead to the most publicized achievement of the National Reactor Testing Station. On December 8, 1953, then-President Eisenhower addressed the United Nations in New York, detailing a new program titled Atoms for Peace.
The atomic age has moved forward at such a pace that every citizen of the world should have some comprehension, at least in comparative terms, of the extent of this development, of the utmost significance to every one of us. Clearly, if the peoples of the world are to conduct an intelligent search for peace, they must be armed with the significant facts of today's existence. This would seek more than the mere reduction or elimination of atomic materials for military purposes. It is not enough to take this weapon out of the hands of the soldiers. It must be put into the hands of those who will know how to strip its military casing and adapt it to the arts of peace. The United States knows that if the fearful trend of atomic military buildup can be reversed, this greatest of destructive forces can be developed into a great boon for the benefit of all mankind. The United States knows that peaceful power from atomic energy is no dream of the future. That capability, already proved, is here Now, today,
The program aligned well with objectives at the East Idaho testing stations and would result in the first town to be lit entirely by atomic energy. Through incentives from the Atoms for Peace project, scientists at the National Reactor Testing Station turned their attention to a small town on the edge of the Big Lost River Desert. The first step for scientists was to develop a new experimental reactor that would facilitate the test. The Borax-3 reactor was created in 1955 to serve such a purpose, and on July 17, 1955, Arco, Idaho became the first town in the world to be lit entirely by atomic energy. Borax-3 would go on to light different sectors of the testing station until it was decommissioned in 1956. While Arco, Idaho stands as a symbol of the atomic advancements achieved by the National Reactor Testing Station during the atomic era, another small town represents an additional first that occurred on the site of the nuclear testing grounds. Atomic City is an all but abandoned ghost town in the Big Lost River Desert. It stands a forgotten reminder of the era which it was named after. Atomic City represents another side to the atomic story, one that would ultimately see the atomic era end in fear. 5 miles outside of Atomic City was the site of another experimental reactor, the Stationary Low-Power Reactor No. 1, known as SL-1. While it has often been wondered if what happened at the SL-1 was an act of sabotage, what is known is that on January 3, 1961, the 3 military personnel working in the control room of SL-1 noticed a problem with nuclear rods that they were monitoring. The energy created by the rods forced said rods to move up and down, but by no more than 4 inches. On January 3rd, however, one of the men noticed that the rods were sticking. Another one of the men, John A. Burns, working at the reactor, stepped into the core where the rods were located. For an unknown reason, Burns pulled out one of the rods by 2 feet, which resulted in an explosion. The rods impaled Burns to the ceiling of the reactor, and he died instantly. A second man, R.C. Legg, was thrown against a wall in the control room and died at the scene. The third man, Richard Leroy McKinley, survived for several hours after, but died from radiation burns while waiting for doctors to arrive from Idaho Falls. Tammy Thatcher, former nuclear safety analyst at the Idaho National Laboratory, has added important analysis of the SL-1 disaster, noting that examination of the SL-1 core after the accident would reveal faulty welds, excessive corrosion, and buckled boron strips. It would be noted in the final report that all materials used in a reactor should undergo rigid quality control and materials testing in both selection and fabrication, and materials should be periodically examined to confirm their suitability. All 3 men were highly radioactive and buried in lead as a result. The SL-1 explosion was the first and only fatal nuclear reactor accident in the history of the United States. With the disaster of SL-1 and the media release of the Tsar Bomba, the world's largest hydrogen bomb created by the Soviet Union, the end of the atomic era was shrouded not by what could be achieved through the energy of atoms, but by fear of how they could destroy. By 1974, the Atoms for Peace program was also over, and the atomic era moved into the shadows. Like Atomic City, the atomic era continues to move further into obscurity, but the National Reactor Testing Station, now the INL, continues to make advances in nuclear technology, as one of 7 testing facilities still active in the United States. The contributions made at the experimental reactors in the Idaho desert serve as a reminder that beyond the fascinating terror of nuclear bomb testing in the U.S. desert, was another, just as important type of atomic testing taking place in the deserts of eastern Idaho, and the achievements made in East Idaho during the atomic era continue to propel the Idaho National Laboratory in future achievements of atomic energy.